Hello, Precalculus student. This video is for chapter 3.2, Quadratic Function, part 3. In this one, we're going to talk about the very main features of a quadratic function. The reason why we are so interested in quadratic function is because it turns. So it has either a maximum or minimum point, and it is really useful to determine the maximum or minimum of a function. So, we also can use it to determine the domain and range of a function. Using the vertex. So, the last one the last example, I didn't finish writing the equation. So, last time we do f of x equal to a is -2, so the function become f of x equal to -2 x plus 1 square plus 3. So that's what I want to write down. So the next thing is domain and range of a quadratic function. So if someone give you a quadratic function ax squared bx plus c, how do you know what the y value could be? And for domain, it should be all x because you can plug in any x in it. But so what happened is, well, how do you know? Because it turns, it bends. So how do you know what the range, the y value would be? So technically, what you can do is you will find the vertex. The vertex is always function of -b over 2a or f of k. No, or k, or k if it's in vertex form. So if it is pointing up, if a is positive, it's like up parabola, then the domain the domain is already a number, but the range would be everything from the minimum value of f all the way to infinity in terms of y, right? So the range is the k value or f of -b over 2a up to infinity. If a is a negative number, then the parabola face down. So you have a maximum value. So because it's a maximum value, the domain would be from all the way from -infinity all the way to this highest point, the maximum, which is -b over 2a or k. Okay. So this is how you find domain and range of a function if it is written in like general form or vertex form. So for example, I have this function 3x squared minus 6x plus 2. How do I know what is the highest or lowest that we will go? First, look at a, okay, and this is in general form. It's not the hk. You can't read off hk, so you have to find the vertex f of -b over 2a. So, but a is positive. Positive means is facing up. I have a minimum point, right? So the domain is a real number. The range is from this minimum point all the way to infinity. So what is this minimum point? We need to find the vertex, right? Okay, so h would be, again, we just still find a vertex. -b. -b is 6 over 2a is 6, so it's 1. F of 1 would be 3 times 1 minus 6 times 1 plus 2. So 5 minus 6 is -1. So our f of b over 2, our vertex is 1, -1. So all the y would be above it. So this is the this is the lowest, this is the minimum y, right? So all y would be above it. So we'll say domain is all real number because you can plug in anything. Range is from the lowest of -1 all the way to infinity because it's facing up. What about the second one? We found a domain and range of this -x squared plus 4x minus 1. A is equal to -1 because this is a. So we know it's facing down. The domain is all real number, but the range would be from this highest point down, right? All the way from -infinity to this highest point on the vertex. So h first. H is -b over 2a, -4 over 2a is -2. So it's 2, okay? And then we want to find the y value, k. K is f of 2. So -2 squared plus 4 times 2 minus 1. So it is -4 plus 8 and then minus 1. So it is 3, right? Plus 8. 8 minus 5 is 3. So this point that you have is 2, 3. And 3 is the highest you can have, right? This is the maximum because you're facing down. And so domain is a real number. Infinity, -infinity to infinity. Range would be from -infinity up to this highest point 3, including it, like that. Okay, if you graph the function, sketch the graph of the function, you can kind of tell. We have two application problem that I want to show you. Quadratic function is very useful to model area because area is length times width, so it would it would involve some kind of square terms, and then also motion. Motions is controlled by gravity, which is proportional to square of time. So that's why it is involving quadratic. The first example, a farmer has some kind of fencing, 360 fencing, but he or she wants to enclose a rectangular area with 2 pens of equal size. So you can draw pictures of the rectangular pen, but you need 2 pens. So doesn't matter, it can be not equal or equal. But so what is the dimension of the greatest area? Rectangle. So for rectangle, we say width is L, W, length is L. Okay. So what is the dimension of the greatest area? So to find greatest area, we want to find the area function first. So area is length times width, right? Length multiply width. This is a multiply. But this is 2 variable, is not a quadratic. So how do I change it so that it's 1 variable? So we know some information between W and L because all in all, I use 360 feet. So this is W, and the other side is also L. You can see that 3W plus 2L is equal to 360, right? So that's all the fencing. Usually it's 2W, but because I need a divider to divide it into 2 pens, so that's what I do. Now I want to change it into 1 variable, so I'm going to solve for L. So 360 minus 3W, and then divided by 2. L is 360 minus 3W divided by 2. And I can write it as divided by 2 is 180 minus 3 over 2W. So this is a formula that I can replace into the A function so that instead of writing W, I write 180 minus 3 over 2W. And it works because of the 360 restriction. So this allows us to write W in terms L in terms of W. And if you multiply W into it, it becomes a quadratic equation or a quadratic function, 3 over 2W squared, right? Any quadratic function, so if I rewrite it, A equal to the 3 over 2 W squared, and then minus, yeah, this is minus 3 over 2 W squared plus 180 W. Do you see that this is actually a quadratic function? This doesn't have the C, but you have A and B, and it is facing down, right? If it's facing down, your A, which is the Y, it's kind of like the Y, and this is the X, Y would have a maximum value. So when does the maximum value occur? Occur at the vertex. So let's do negative B over 2A. Negative B over 2A is H, right? H is W. H for W. So negative B is this one, negative 180 over 2 times negative 3 over 2. So that's 3, because negative 3 over 2 times 2 is just negative 3. Negative B over 2A, so that's 60. So when W, okay, so H is W. So because our point is W comma A, right? This is Y is A. The X is W. So when W is 60, you have maximum area. So when W is 60 feet, this would correspond to maximum area. And what is the length? Length is 180 minus 3 over 2 times 60. That is equal to 90. So 90 feet times 60 feet will give a dimension for the greatest area. And you can actually also plug it in. Oh, well, actually A is L times W. A equal to L times W equal to 5,400 feet square. Okay, so that's the maximum area that you can enclose. The second example is about motion. So if you take physics or some kind of beginning of science, you know that vertical motions, we're talking about rockets, so it's vertical motions. Anything that goes up eventually will goes down if it is on Earth, right? And why does it go down? Because of a gravity. And in a vertical motion, the first term of t squared is negative because it always pull it down by gravity. The second is because of force. Force shoot the rocket up, and then the gravity pulls it down. And the last term is the position of the rocket in the beginning. If you have it higher, so in the beginning it would have a high h. So anytime the position of a rocket can be calculated by the gravitational position or like characteristics, the velocity, the force that applied to it, and the initial motion. So after you launch it and the things can be modeled by this, how long would it take to reach maximum height? Maximum height. So height is the y that we have. How long means time, right? What is t so that it is a maximum? See a here, this is a quadratic function, this is a. A is negative, so it is facing down. And you do have a maximum point, right? Where's the maximum occur? At the vertex of hk. And how do I find h? H is negative b over 2a. Whenever you're doing maximum, it is negative b over 2a negative 232.75 over negative 2 times negative 4.9. So it is equal to 23.75. So, and this is seconds. So after 23.75 seconds, it's going to reach the maximum height. And what is the maximum height? Maximum height is the h, the y that we have. So that's the k. Okay. K is the maximum height equal to f of 23.75. So basically plug it in. So that is equal to negative 4.9 times 23.75 square plus 232.75 times 23.75 plus 117.6. Add all these together in the calculator. I did that. So it's 2881.5 and it's meter. So after 20 something second, it would be at this meter and then it would come down. Okay. So this is this number. So basically it's f of h, right? So f of 23.75. The second is after it go to the maximum, it would eventually come down and actually come to the oceans. The ocean is when h of t equal to 0. That means the height is 0. That's what we generally assume. The sea level is the height equal to 0. So that means you are not solving for maximum now. If it is onto the ocean, the height is 0. So you basically solve a quadratic equation. You want to find the x-intercept. So you would write equation as negative 4.9. So x equal to 0, that means 0 equal to negative 4.9 t squared. I forgot the answer. 232 plus 232.75 t plus 117.6. We want to solve this equal to 0. No one's going to try to factor it, so let's just use quadratic formula. So we will say t equal to negative b, negative 232.75 plus or minus b squared. B squared is this one, right? 232.75 squared minus 4a, negative 4.9, c, 117.6, all over negative 9.8, right? So this is plug in the calculator. It turns out that if you square root this, it's 232.75 plus and minus. It's actually a perfect square. 237.65 when I plug this in, and equal to over negative 9.8. So there's two numbers. One of them is positive, one of them is negative. The positive one is when you are doing negative, negative, divide negative. So t is equal to 48. The other one is a negative number. We don't even border, but it doesn't, because it doesn't make sense to be the time when it, okay, let me do it. -20, yeah, I don't have time to do this. But so that would